Hello everyone, and on this video we will be covering solving rational inequalities. Okay, so a few things you want to remember when solving rational inequalities. Okay, these aren't necessarily steps, these are just kind of reminders of things you have to do in order to solve them. Okay, so the first thing is you want to make sure that you move every term to one side and create a single fraction. That's if it's necessary. Okay, now your second thing you want to remember is this time you're factoring the numerator and denominator to find critical points. Okay, so it's a little bit different from solving quadratic inequalities. Okay, because now you have a numerator and denominator to worry about. Okay. Now, once you do those two, then you just go ahead and use the same process of solving quadratic inequalities to find the solutions. Okay, so that part of it doesn't really change. All right. Okay, so let's go ahead and go to our first example. Remember, if you're still writing, feel free to press pause. Just bring that down a little bit. Okay, and please excuse the shadow. The sun is just shining through the window. Okay, so first we want to solve x squared plus x minus 2 divided by x minus 4 is greater than or equal to 0. Okay. So the first thing you want to do, if you remember the steps, is you want to x squared plus x minus 2 over x minus 4 is greater than or equal to 0, is you want to solve the equality or the equation. Okay, that means x squared plus x minus 2 over x minus 4 equals 0. Okay, so we're going to go ahead and factor the x squared plus x minus 2, and that factors to become x plus 2 times x minus 1. So instead of x squared plus x minus 2, we just factor that out. So make it over x minus 4 equals 0. Okay, so how do we know that equals 0? One thing you want to do is you want to remember that 0 divided by any number, clean it up, 0 divided by any non-zero number is equal to 0. Okay, so that means all we have to do is make our numerator equal to 0, and that will make this true. Okay, so x plus 2 equals 0, or x minus 1 can equal 0. Okay, so if we subtract 2 from both sides here, we have x equals negative 2. And if we add 1 to both sides here, we have x equals 1. Okay, so we have our critical numbers. Okay, but remember, this is not a quadratic equation, this is a rational equation, so you have to take the denominator into consideration, because we know that the denominator can never equal 0. The numerator can equal 0, but the denominator can't. Okay, so we know since x can't equal, well, x minus 4, let me write it out first. X minus 4 can't equal 0. If we add 4 to both sides, we know that x can't equal 4. Okay, so So this lets us know also that x equals 4 is also a critical number. Okay. Now the reason this is a little bit different is because your denominator critical numbers can never, ever, ever use the bracket, because the bracket shows that it can't equal that value. It can equal, values other than that, but it can't equal that value. That's what the bracket means. But whenever you have your denominator critical numbers, those will never, ever, ever use the brackets. But you cannot use brackets in your solution. Okay, so we have our 3 critical numbers. Okay, so we're going to go ahead and go to our second step, which is our number line. Let me go ahead and just kind of separate that a little bit. Okay, so we have -2, 1, and 4. Okay, so we have -2, 1, and 4. And just like the quadratics, you go ahead and draw a little dotted line. Uh-oh. Okay, so this goes from -infinity to +infinity. So for each section, we know that this section is from -infinity to 2. Now remember, that's in our numerator, so we can use brackets for those since we have greater than or equal to. So we use the bracket for that one. Now from -2 to 1, again, those are in the numerator, so we can use the brackets for those. We have -2 to 1. Okay. Now from 1 to 4, 1 is a critical point in our numerator, so we can use the bracket for that critical point. But 4 is the critical point of our denominator. And remember, for that one, you have to use parentheses. And from 4 to infinity, you have from 4 to infinity. Okay, so those denominator critical numbers, remember, you cannot use the bracket for the denominator critical numbers, just the numerator critical numbers. Okay, so if we go ahead and pick our test values, which is our third step. So between -infinity and 2, oh, -2, sorry about that. We're going to pick x equals -3. Okay, from -2 to 1, we're going to pick x equals 0. From 1 to 4, we're going to pick x equals 2. And from 4 to infinity, I'm just going to pick x equals 5. All right. So again, we're just going to go ahead and plug that in, but instead of our original inequality, we can go ahead and plug it into, because this is just factored, we can use x plus 2 times x minus 1 over x minus 4. Oh, let me move that out the way. Is greater than or equal to 0. Okay, because remember, that's just the equivalent of this one. It's just factored, so it's the exact same thing. So when we plug in our values, we can use this one. It's a lot easier. All right, so if we pick x equals -3, that's -3 plus 2 times -3 minus 1 over negative 3 minus 4 is greater than or equal to 0. And go ahead and move that up. Okay, so negative 3 plus 2 is negative 1. So we have negative 1. Negative 3 minus 1 is negative 4. Negative 3 minus 4 is negative 7. Greater than or equal to 0. Negative 1 times negative 4 is positive 4. Over negative 7 is greater than or equal to 0, which is false. Okay, so we know that this is not part of our solution interval. Oh, that arrow goes to that one. Okay, so from negative 2 to 1, we picked x equals 0. So we have 0 plus 2, again, just plugging it into that one, times 0 minus 1 over 0 minus 4 is greater than or equal to 0. We'll clean that up a little bit. Alright, 0 plus 2 is 2. 0 minus 1 is negative 1. And 0 minus 4 is negative 4. Greater than or equal to 0. 2 times negative 1 is negative 2. Over negative 4 is greater than or equal to 0. Negative divided by negative is positive. That's 2 over 4 is greater than or equal to 0, which is true. So this is part of our solution. Okay, we can figure that by just not crossing it out. You don't have to write part of solution if you don't want to. Okay, so let's go ahead to our next test value. So picking x equals 2, we have 2 plus 2 times 2 minus 1 over 2 minus 4 is greater than or equal to 0. Okay, 2 plus 2 is 4, so we have 4. 2 minus 1 is 1. All over negative 2 is greater than or equal to 0. So you have 4 times, let's say 4 over negative 2 is greater than or equal to 0. So that gives us negative 2 is greater than or equal to 0, which is false. So we know that this is not part of our solution. So now we pick x equals 5. Go ahead and plug that in. So we have 5 plus 2 times 5 minus 1 over 5 minus 4 is greater than or equal to 0. 5 plus 2 is 7. So we have 7. 5 minus 1 is 4. All over 1 is greater than or equal to 0. So that gives us 28 is greater than or equal to 0, which is true. Okay, so we know that this is part of our solution. Alright, so we're going to continue that on the next page because we're running out of room. An extra sheet here. Alright, just in case you are still writing. So if you're still writing, feel free to press pause. We're going to go ahead and move on. Alright, so now all we have to do now is go on to our fourth step. So if we went ahead and rewrite our graph and our critical points is negative 2, 1, and 4. We know that our solution, getting our previous page real quick, we know from negative 2 to 1 and 4 to infinity are parts of our solution. So from negative 2 to 1, we're going to shade that in Okay, and from 4 to infinity, remember 4 is your denominator critical number. So that's going to have the parentheses. So you have from 4 to infinity. I'm going to go ahead and shade that in. Okay, so that's the graph of your solution, but your solution interval is from -2 to 1 or from 4 to infinity. Okay, so that would be your solution interval. All right. Okay, so if you're still writing, feel free to press pause, but we're going to go ahead and go to our next example. Straighten up the papers here. Okay, so what if we wanted to solve 3 over x minus 1 is less than 2 over x? Okay, so if you remember from the very beginning, you want to move everything to one side of the inequality symbol and make it one fraction before you do anything else. All right. Okay, so make into a single fraction before starting. Okay, so before you start your steps and all of your critical points and everything else, you want to make it a single fraction first. Okay, so what I mean by that is if you have 3 over x minus 1 is less than 2 over x, we're going to subtract 2 over x from both sides, where those two cancel out. So that gives us 3 over x minus 1 minus 2 over x is less than 0. Okay, so now what we're going to do is we're going to combine these two. So if we have 3 over x minus 1 minus 2 over x, and I'll give that a little bit of space. To get these to have the same denominator, we multiply this denominator over here. So you have x over x. And this one we're going to multiply times x minus 1. I needed a little more room. X minus 1 over x minus 1 is less than 0. Okay, so all we're doing is we're getting our common denominators. Okay, so 3 times x, that's 3x over x times x minus 1. I could have made that a little shorter. Minus 2 times x minus 1. If we go ahead and distribute the 2, that'll be minus 2x. And actually, the reason I made that longer, I was going to skip the step, but we have x times x minus 1, x times x minus 1. We can put them both over the same fraction. So that 3 times x gives our 3x. Negative 2 times x is minus 2x. And negative 2 times negative 1. Oh, it's plus 2. Sorry about that. There we go. And that's less than 0. Okay, so all we did was take those two separate fractions, give them like denominators, and then just add them together. So if we go ahead and combine those two, 3x minus x gives us just x. So you have x plus 2 over, we don't combine these. These are already factored, so we want that. X times x minus 1 is less than 0. Okay, so before we started, we just went ahead and moved those over and subtracted them and made them all one nice, neat equivalent fraction. Okay, so this is what we're going to solve now. This will give us all of our critical points. Okay, so now that we've done that, now we go ahead and start our steps. Okay, remember your first step, you want to solve the equality. Okay, so you have x plus 2 over x times x minus 1 equals 0. Okay? So remember, 0 divided by anything is 0. So that just means that x plus 2 can equal 0. Or in this case, if you subtract 2 from both sides, x can equal negative 2. Okay, so that's our critical number. But remember, your denominator also has a critical number. Okay, so that means that x times x minus 1 cannot equal 0. So that means x cannot equal 0, and x minus 1 can equal 0. So that means x cannot equal 1. Okay, so remember, whenever you have your denominator critical numbers, but because they're in the denominator, they're parentheses only. Okay, now the whole thing is going to be parentheses because you have less than, but this is just something that you really want to be conscious of. Okay, whenever you have your denominator critical numbers, it's always going to be parentheses. The numerator critical numbers depends on the less than or equal to. Okay, so even though it's all going to be parentheses, I still wanted to point that out. Okay, so you have your 3 critical numbers. Okay, so go ahead and go to our second step, which is our number line. So go ahead and get that. So we have from negative infinity to infinity, and we can go ahead and separate that. Okay, so if we put all of our critical numbers, so we have our negative 2, and we have 0, and we have 1. Okay, so we have all of our critical numbers. Okay, so just like before, this is from negative infinity to negative 2. This interval is from negative 2 to 0. This is from 0 to 1. And this is from 1 to infinity. And we're going to go ahead and separate those. All right, so now we pick our third step, which is picking our test values. Between negative infinity and negative 2, I'm going to pick x equals negative 3. Between negative 2 and 0, we can't pick 0. So we'll pick x equals negative 1. Between 0 and 1, I'm going to pick x equals 0.5 or 1/2. And from 1 to infinity, I'm going to pick x equals 2. All right. Now for these, I'm going to kind of use a shortcut. And again, we're going to use x plus 2 over x times x minus 1 is less than 0. We're going to use this one. Oh, well, I already had it written down, so didn't have to write it again. All right, so if we plug in x equals -3, -3 plus 2 over -3 times -3 minus 1 is less than 0. Okay, so -3 plus 2 is -1 over -3. -3 minus 1 is -4 is less than 0. Okay. Now, if you want to, you don't have to multiply these out. If you have a negative number in your numerator, you know that's a negative number. In your denominator, negative times negative is positive. So you know that's going to be a positive number. Okay. Negative divided by positive is negative. So a negative number is less than 0 is true. Okay. So that means from -infinity to -2 is a solution interval. So we're not going to cross that out. Okay, so what about from -2 to 0? You pick x equals -1. So that's -1 plus 2 over -1 times -1 minus 1 is less than 0. Again, just plugging -1 into there. All right. -1 plus 2 is +1 over -1 times -1 times -1 is -2 is less than 0. And again, you have a positive number in your numerator. Negative times negative is positive, so you have a positive number in your denominator. Positive divided by positive is positive. So a positive number is less than 0 is false. So you can go ahead and cross that out. Okay, so from 0 to 1, we picked 0.5. And this is where the shortcuts really come in handy when you have your decimal numbers. So 0.5, so we have 0.5 plus 2 over, move that over a little bit. So that's 0.5 times 0.5 minus 1 is less than 0. Okay, and again, if you don't feel like doing all the decimal numbers, you can have the 0.5 plus 2 is positive over, you have a positive number times 0.5 minus 1 is a negative number, is less than 0. So that gives you a positive number divided by a negative number is less than 0. Positive divided by negative is negative, so a negative number being less than 0 is true. Alright, so we have our last one. We pick x equals 2. So that gives us 2 plus 2 over 2 times 2 minus 1 is less than 0. So that's 4 over 2 times 1 is less than 0. That's pretty quick, so we just know that 4 divided by 2 is 2. 2 is less than 0 is false. So we can go ahead and cross that one out. Alright, so we're going to continue this on the next page. If you are still writing, please feel free to press pause. But we're going to go ahead and continue. Give that extra sheet there. Alright, so that brings us to our fourth step, writing our solution. So if we go ahead and write down all of our critical numbers, so we have -2, 0, and 1. Oh, straighten that up some. There we go. You can see from the previous page that from -infinity to -2 and from 0 to 1, are true. Okay, so we're going to use parentheses. So -2, well, negative infinity to -2, and from 0 to 1. Okay, so that's the graph of your solution. And I can put this up, so our solution interval is from negative infinity to -2, or from 0 to 1. All right. Okay, so again, if you're still writing, feel free to press pause. But we're going to go ahead and go to our next example. Let me straighten up the papers here. Okay, so what I want you to do now is I want you to press pause and solve this one on your own, or at least give it a try. Alright, so assuming that you have already pressed pause and tried to solve this one on your own, let's go ahead and verify your answer. Okay, so we have 1 over x squared plus 7x plus 12 is greater than or equal to 0. Thing is, 0 divided by any number is 0. There is no way that 1 will never equal 0. So this will never equal 0. But if we factor it out, basically for our first step, we have 1 over x squared plus 7x plus 12 factors to become x plus 3 times x plus 4 equals 0. Again, we know that will never equal 0, but we do have our critical points in the denominator. So since the numerator will never equal 0, the denominator will give the only critical points. Okay, so we don't have our numerator critical points, but we do have our denominator critical points. So x plus 3 can't equal 0, and x plus 4 can't equal 0. So x can't equal -3, x can't equal -4. So x equals -3, x equals -4 are your only critical points. Okay, but remember, they're denominator critical points. And denominator critical points are parentheses only. Doesn't even matter what that is. When you have denominator critical points, parentheses only. Alright. So we go ahead to our second step, where we draw our number line from negative infinity to positive infinity. And we put our critical points, -3 to -4. Okay, so we have, well, -4 to -3. -4 here, and we have -3 here. And we can go ahead and draw our dotted line. And we know this interval is from negative infinity to negative 4. Remember, it's a denominator critical point, so it's going to be parentheses. Not even worried about that one. That's mainly for the numerator. Denominator critical points, always, always, always parentheses. All right, so you have here from negative 4 to negative 3. And from here you have from negative 3 to positive infinity. All right, so again, we go to our third step where we pick our test values. From negative infinity to negative 4, we're going to pick x equals negative 5. From negative 4 to negative 3, we're going to pick x equals negative 3.5. From 3 to infinity, we're going to pick our old reliable x equals 0. Okay. Now remember, you can plug them into that one, but it will be easier to use 1 over x plus 3 times x plus 4 is greater than or equal to 0. Okay, same thing, it's just we factored the denominator. Okay, so if we pick x equals negative 5, we plug that in. We have 1 over negative 5 plus 3 times negative 5 plus 4 is greater than or equal to 0. Oh, let me move that up. Here we go. So just plugged in negative 5 into that one. So that's 1. Negative 5 plus 3 is negative 2. Negative 5 plus 4 is negative 1. So that gives us 1 over negative times negative is positive. So 1/2 is greater than 0, which is true. Okay, so we're not going to cross this one out. Now if we pick negative 3.5, again, we just go ahead and plug it in. So you have 1 over negative 3.5 plus 3 times negative 3.5 plus 4 is greater than or equal to 0. Okay, so if you really don't feel like being bothered, let me clear that up just a little bit. Negative 3.5, there we go. Now, if you don't really want to be bothered with trying to add and subtract decimals and all that good stuff, remember, you have 1 in your numerator, which is positive. Negative 3.5 plus 3, the negative value is a larger absolute value, so we know that's going to be negative, whatever your answer is. If you want to work it out, you can. Negative 3.5 plus 4, the 4 is the larger absolute value, so we know that's going to be positive. So that gives you a positive value over a negative times positive is negative. Greater than or equal to 0. Positive divided by negative is negative. So here we have a negative is greater than or equal to 0, which is false. There's no negative number that's larger than 0, so we can go ahead and cross that one out. Okay, now we pick our x equals 0, and that gives us 1 over 0 plus 3 times 0 plus 4 is greater than or equal to 0, or 1 over 3 times 4. Okay, so that gives us basically 1 over 12 is greater than or equal to 0, which is true. Okay, so we don't cross this one out. Alright, so now we go ahead to our fourth step where we put this on a graph. Okay, so we have negative 4 to negative 3. We know from negative infinity to negative 4, we're going to shade that in because we did not cross it out. And from -3 to infinity, we're going to shade that in because we did not cross it out. Okay, and both of those will have parentheses. Okay, but our solution interval will be from -infinity to -4, or from -3 to +infinity. Okay, so that is our solution interval for that problem. Alright, so if you're still writing, feel free to press pause. But we're going to go ahead to our final example, which is a word problem. Okay, so we have the function c of x is equal to 300x plus 6,000, which represents the cost to produce x number of items. How many items should be produced so that the average cost is less than $500? Okay, so if you're still writing this down, feel free to pause it, but we're going to go ahead and get started on this one. Okay, now the first thing you want to do is find the average inequality, average cost inequality. Or basically just the equation that you're dealing with. Okay. Now if you remember, this is just an example of an example. An average is equal to, let's say if you have 4 plus 3 plus 5 plus 7 plus 2 plus 9. To find the average of those values, you divide it by the number of terms. So you have 1, 2, 3, 4, 5, 6. So you divide that by 6. That's how you find your average value. So this is the same thing if you think about it. You get your equation, because if you plug in 1, it's just going to be that plus 1. If you plug in 2, it's going to be that plus 2. So your equation is 300x plus 6,000 divided by your number of items. Okay, that's your average cost. Oh, why did I put the line there? Okay, so that's your average cost. Okay, so what we want to do is find that average cost to be less than 500. So we need to find 300x plus 6,000 divided by x is less than 500. Okay, it didn't say less than or equal to, just said less than. Okay, so that gives us our average cost is less than 500. All right, so we're going to go ahead and start to solve this one. So our first step is we're going to solve the equality. So if we subtract 500 from both sides, we get 300x plus 6,000 over x. You subtracted 500 from both sides, so that's minus 500. And we're looking for the equation, the equal sign. So we're going to solve for equals 0. All right. So we can't add or subtract or make that just simply one equation unless we have common denominators. So we have 300x plus 6,000 over x minus 500x over x equals 0. Okay, so now we have our like denominators. So we can put them all over the same denominator. So you have 300x plus 6,000 minus 500x equals 0. We can go ahead and combine those two. 300x minus 500x is negative 200x. plus 6,000 divided by x equals 0. Okay. Now we know that this is going to be true when we make that equal to 0, but we can make our work a little easier. Just factor negative 200 out of both of those. Okay, so you have negative 200 times x minus 30 over x equals 0. All right. So if we divide both sides by negative 200, you have 0 divided by negative 200, which is 0, so that would cancel out. So we have x minus 30 over x equals 0. Okay, so that means that x minus 30 equals 0. Because remember, 0 divided by anything will be 0. Add 30 to both sides. We have x equals 30. So that's our critical point. But remember, your denominator can't equal 0. So we know that x cannot equal 0. I'll separate that a little bit. Okay, so we know that x equals 0 is also a critical point. All right. Now we're not going to graph this one. We're just looking to solve it so we don't have to worry about your parentheses and brackets and all that good stuff. Okay, at least in our final answer. All right, so we're going to continue this on the next page. If you're still writing, feel free to press pause. We're going to go ahead and continue. And let me all right. So now, for our second step, go ahead and make our number line. We have our infinity. Let me clean that up some. And negative infinity. Okay. Now the one thing is you have your 0 and you have your 30. And I'm just going to put the 30. And here's why. It's going back to the previous page. If you sold 0, your average cost would not be less than 500. So you can't, move that up some, sorry about that. If you sold 0, your average cost can't be less than 500. Because if you plug in 0, again, you have your denominator of 0, which can't be. All right. So here, we don't even have to, even though this is a critical number, this is not a possible answer. We can't use anything in that one. Well, we can use it, but we can't use the actual value of 0. But what I will show you is, when we put our 0 here, it can't be any negative value. You can't sell a negative number, so we don't even have to look there. Okay? So really, we're just going to use two sides of the 30. Because you're going to sell between 0 and 30. Or you're going to sell from 30 to an infinite number. Okay. So the 0 really didn't even have to be put down because we're not going to sell a negative number. We're not going to sell 0. But just for visual aid, I went ahead and put it down. All right. So now we go ahead and go to our third step, which is picking a random value. So really go ahead and draw our little dotted line there. So between 0 and 30, we can pick x equals 1. Between 30 and infinity, we can pick x equals 31. Okay, now we go ahead and plug them in. Alright, so to pick the value, remember, just going back really quick, we started off here, but we simplified it to this one. So you can plug it here if you want to, but an equivalent equation of this is just this one. And this one's a whole lot easier, or you can just use this right here. Okay? Okay, so we're going to use x minus 30 over x is less than 0. Or you can put negative 200 times that less than 0, whichever one works for you. Alright, so if we plug in x equals 1, oh, actually it should be the negative 200, since that is the equivalent equation. Oops. We have negative 200 times x minus 30. Sorry about the dirty pencil. There we go. Well, a dirty pencil eraser. Alright, so if we use that one, we have from 0 to 30, we picked x equals 1, so that gives us negative 200 times 1 minus 30 all over 1 is less than 0. Okay, so we have negative 200 times 1 minus 30. So we have a negative number, which is the negative 200. 1 minus 30 is also a negative number, all over a positive 1, less than 0. Negative times negative is positive. So we have a positive number divided by a positive number, which is less than 0. Which is false. Because positive divided by positive is positive, there's no positive number less than 0. Okay? We can cross that one out. Okay? Now pick from 30 to infinity. You have negative 200 times 31 minus 30 all over 31. Is less than 0. Okay, so you have a negative 200, which is a negative number. Well, actually, you can go ahead and solve this one since it's really simple. Because you have negative 200, 31 minus 30 is just 1. All over 31 is less than 0. So really that's just negative 200 over 31 is less than 0. Negative divided by positive is negative. So this is true. Okay, so what this lets us know is that for our solution, that we must produce, more than 30 items to keep, sorry about that, costs under $500. All right. Okay, so hopefully that made a little sense, and I will see you on the next video.